Hypothalamus Artificial Intelligence, HI, presents the conference. Industry 6.0, State-of-the-Art of Optimization for Enterprise-Wide Optimization Systems. HI is supported by its technology partners. GAMS, IBM, and TD SYNNEX. The topics of the conference are Digital Revolutions, Artificial Brains, Industry 6.0 Algorithms, Quantum Computing, GPT Projects, and Software Factory. Here and Now of Artificial Intelligence. HI and its partners understand that professionals face increasingly complex challenges. Mathematical modeling as a service ensures more reliable and efficient operations in the electricity and gas sectors, while integrating renewable energy intelligently. This technology is growing rapidly, as traditional tools do not respond to the scale, speed, and complexity of modern decision-making. Add to this the fragmentation of data, the pressure for greater transparency in planning, and the high cost of suboptimal decisions. It's clear, incremental improvements aren't enough, what's needed is structural change. Imagine a system capable of orchestrating all your energy assets with a unified decision engine, from automatic dispatch modeling to energy trading and risk management, including emissions, maintenance constraints, all in real time. This allows your teams to anticipate, simulate, and optimize every operational decision, turning uncertainty modeling into a strategic advantage. State-of-the-art of optimization. The accelerated evolution of artificial intelligence is supported by the growth, also accelerated, of computing. This has enabled the development of a robust library of algorithms, application development, and successful use cases in large global enterprises. With applications in general industry, energy, oil, gas, mining, agriculture, transportation, finance, education, regional planning, and others. This growth is supported by a new look at optimization, which is totally different from what most executives and managers knew in the past. This has allowed the creation of new concepts such as the artificial brain, which is the widespread use of multi-problem mathematical models in parallel, in real time. This approach is totally different from the past, in which mathematical models were reduced to solving an individual problem, and not to an integrated system oriented towards the holistic optimization of companies. Digital Industrial Revolutions. Today, the evolution of industrial revolutions is conceived as Industry 6.0 is completely changing the mathematical modeling of artificial intelligence. Now we can talk about orchestration of swarms of cognitive robots, and living industrial ecosystems. These two terms are new to most people, including scientists, even though they date back at least 15 years. Industry 4.0 is a consequence of the invention of the digital computer and digital automation. Its origin may be in 2011, and the result is digitalization and interconnectivity, smart factories, that is, cyber-physical systems. Industry 5.0, the first mentions date back to 2015, is humanization and close collaboration between people and cyber-physical cognitive robots based on artificial intelligence. The transition from Industry 4.0 to Industry 5.0 represents a paradigm shift. We move from an approach focused exclusively on technological efficiency to one that prioritizes human value, sustainability, and resilience. While Industry 4.0 sought to interconnect machines so that they could make autonomous decisions, Industry 5.0 seeks to make these machines work with people to enhance their creativity and well-being. Formally introduced by the European Commission in 2021, this revolution does not replace the previous one, but complements it under three fundamental concepts. Human centrism: technology should serve people, not the other way around. It focuses on improving the health, safety, and job satisfaction of workers. Sustainability prioritizes circular processes that reuse resources, reduce environmental impact, and respect the planet's limits. And resilience, the industry's ability to withstand and adapt quickly to global crises, such as pandemics or supply chain disruptions. Industry 6.0 currently has no date, as it is considered a visionary and conceptual phase that is still being defined, but which is based on intensive artificial intelligence. Total autonomy, biological symbiosis and industrial systems that function as living organisms, There are already examples of this situation, as is the case with smart grids and the Internet of Energy. Industry 6.0 focuses on the total symbiosis between humans, machines and biological systems to create living, regenerative and deeply ethical industrial ecosystems. Unlike its predecessors, it does not seek only efficiency or collaboration, but an integration where technology self-organizes and evolves along with society. The fundamental pillars are: integration of mathematics and artificial intelligence, to produce artificial general intelligence, AGI, with the ability to understand, learn and apply knowledge in any intellectual task, in the same way, or even better than a human being. Human-machine biology symbiosis, fusion of human intuition, advanced artificial intelligence, and biological systems, such as self-healing materials or neurocognitive interfaces. Cognitive and proactive autonomy, transition from predictive maintenance to self-regulation and regeneration. Systems not only detect faults but are reconfigured to avoid them altogether. Regenerative sustainability, beyond reducing environmental damage, systems are designed to actively restore and enhance ecosystems through real-time circular economies, and ethical and conscious governance. AI incorporates moral reasoning and transparency, ensuring that autonomous decisions are aligned with human values and planetary well-being. The technologies related to Industry 6.0 are: mathematical modeling, translation of real-world problems into a mathematical language, such as formulas, equations, or graphs, to understand, analyze, and predict behaviors of complex systems. Generative AI and AGI, co-creation of workflows and autonomous design of products based on abstract objectives. Quantum computing, massive data processing for optimization of ultra-complex supply chains and molecular simulations. Human digital twins, HDT, virtual replicas that simulate not only physical processes, but also emotional and cognitive dynamics of workers. Internet of Everything, I/O, and 6G, ubiquitous and ultra-low latency connectivity that enables the orchestration of swarms of cognitive robots and devices on a global and even spatial scale. Industry 6.0. A swarm of artificial intelligence algorithms, that is the orchestration of swarms of cognitive robots on a global scale. One aspect that becomes fundamental is the lives of professional people. Although professional development normally evolves to its maximum level at the end of university, however, it is common for professionals to lose knowledge during the exercise of their work and reach low levels of useful scientific knowledge. In the example, after high knowledge developed at the university, the actual exercise is limited to Excel, which is fundamentally arithmetic. This is another barrier that must be overcome. Now GPT is the intelligent, and super-fast, consultation of what is recorded on the internet, which limits many professionals to this knowledge. In 2020 there was already an awareness that the impact of industrial revolutions could be negative, and that this is apparently still happening. Digital natives are the first children with a lower IQ than their parents. This originates in the scientific gap that is forming. The difference between a scientific life and a real and ordinary life generate a big chasm, not a gap. Artificial brains. In the technology and business sector, Hypothalamus I uses artificial brains, a comprehensive multi-problem model that coordinates the company's operations. It is made up of cognitive robots. The system integrates multiple AI algorithms that act as cognitive robots to solve large-scale optimization problems, such as supply chain planning in any sector. Distributed optimization. It uses concepts of real-time distributed optimization to get different digital agents to cooperate simultaneously, emulating the way the human hypothalamus maintains internal balance. Concepts are updated to Industry 6.0. OpTech structured mathematical modeling allows model cases using large-scale optimization methodologies, such as Bender's theory and Lagrangian relaxation. The concept of model integration is applied in multiple dimensions. For example, an integrated oil company can be conceptualized based on the operation of 4 businesses: production, crude oil transport, refining, and transport of derivatives. In this case, the complete model of the company corresponds to the integration of the 4 models. For example, the figure represents a mathematical model for a multi-business enterprise that operates 3 business, electricity, oil and gas. The integrated model of the company will be the union of the three super problems. However, the modularity of the modeling allows to have individual models for each business. These models can exist as an integrated model, or as three individual models, one for each filial. In this case, the data communication for the integrated multi-business model is defined by the Lagrangian relaxation methodology. Under a hierarchical conception, each subsidiary can be divided into sub-businesses that can be planned in a coordinate or integrate manner. Coordinating, when each individual model connects with another model to send its optimal decisions resulting from an isolated planning. Integrating, when all models are part of a holistic model that produces the real optimal decisions for the enterprise. The image shows an artificial hypothalamus typical of Industry 4.0, which is based on an integrated problem, which is solved using large-scale optimization techniques. The coordinating brain can be associated with the master problem that coordinates all subproblems. The master problem emulates the decision of the board of directors. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus of the company is obtained. This is how the human brain faces reality. Multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by Optex, using the models that traditionally make up a decision support system. The concept of artificial hypothalamus can be applied to solve real-life problems from multiple points of view. In the diagram, the artificial hypothalamus coordinates models corresponding to the multiple problems faced by a company, organized from the point of view of its administrative functions. The image focuses on the problems faced by a company's vice president of marketing and sales. Industry 6.0 focuses on the symbiosis between humans, machines and biological systems to create living, regenerative and deeply ethical industrial ecosystems. Unlike its predecessors, it does not seek only efficiency or collaboration, but an integration where technology self-organizes and evolves along with society. Industry 6.0 is changing the mathematical modeling. Now we can talk about living industrial ecosystems, and orchestration of swarms of cognitive robots. This has led to the fact that, if desired, modeling in Industry 6.0 is autonomous, without human participation or coordination problems. Consensus algorithms are fundamental to the operation of decentralized networks. They ensure that all network participants agree on the validity of transactions. Without consensus, there would be discrepancies in the data between different nodes, which could lead to fraud and errors. These algorithms facilitate trust between users who may not know or trust each other. Different consensus mechanisms have been developed to respond to the needs of various applications, each with its own strengths and weaknesses. In the case of mathematical programming, the rules of consensus are exact. In Industry 6.0, modeling is more aligned with the artificial brain, which has organs that function autonomously and independently, without an explicit coordinator managing the process. Coordination is done using a consensus algorithm, which are mathematical rules, like Lagrange's theory, and not a coordination problem. One of the most impactful changes occurs with the arrival of the Internet of Things, IoT, which began to change the models that ran at discrete frequencies, such as days, weeks, months, for real-time models. It can be said that in Industry 6.0 all models work in real time, so that the world reacts distributed and online, for all IoT-connected systems. For static systems, the methodology is also valid, but the world is dynamic. IoT enables all models associated with Industry 6.0. Dispatch of an agro-industrial supply chain. Normally, an agro-industrial chain must be planned integrally, which involves coordinating many farms. IoT facilitates the knowledge of the status of each farm, in such a way that each of them can be planned autonomously and independently, following the principles of Industry 6.0. Another point of view is the spatial distribution of the problem. In this case, an artificial hypothalamus is presented for an agro-industrial company that has multiple facilities, farms, concentrated food factory, meat products factory, and stores in the food market. In Industry 4.0, for long and medium-term planning, it is possible to solve the problem using a monolithic model solved with large-scale optimization methodologies. The entire relationship between the optimization models is stored in the expert system. In real time, using an IoT system, the best solution is based on the principles of Industry 6.0, mainly on the coordination of farms, which can be many. Coordination is done using a consensus algorithm, which are mathematical rules, like Lagrange's theory, and not a coordination problem. OpTex, Optimization Expert System, is the generative artificial intelligence created by HI that builds enterprise-wide optimization systems for global companies. An expert system, S, is a computer system designed to emulate the reasoning and decision-making ability of a human specialist in a very specific area of knowledge. It is one of the most classic and successful applications of artificial intelligence, AI, gaining great popularity between the 1970s and 1980s. Unlike traditional programs based on rigid algorithms, an expert system uses structured knowledge, rules, facts, and heuristics to solve complex problems that would normally require years of human experience. OpTex is an optimization expert system that helps the mathematical modeler and the user of the models to manage them. The result is that OpTex manages mathematical models without using programmers. The image shows the structure of a traditional expert system, which incorporates a human expert, who possesses the knowledge, a computer engineer, specialized in capturing the expert's knowledge, and a user who doesn't have to be an expert on the subject. The computational architecture of the expert system integrates three parts: knowledge database, inference engine, and human interface. As an expert system for a scientific topic, such as mathematical modeling, OpTex is accurate and does not require synthesizing the knowledge of experts who may differ in their opinions, which facilitates the commissioning of the system. In practice, the human expert, with computer knowledge, is a mathematical modeler, and the implementation of OpTex is summarized as the intelligent management of the knowledge database. In this way, a non-expert in mathematical modeling can manage OpTex, without the need to build programs. OpTex, Optimization Expert System, is the optimization technology that allows you to assemble multi-problem mathematical models like a Lego game. Can you imagine how? Imagination is the beginning of creation. You imagine what you desire, you will what you imagine, and at last, you create what you will. By George Bernard Shaw. OpTex, the expert system for optimization, is used as the way to develop and implement AWO solutions, in which multiple mathematical models converge, and can be connected via a disk or cache databases, to form a monolithic model of the enterprise. OpTex is the generative artificial intelligence produced by HI, which manufactures optimization systems for the entire company. Created in 1991, OpTex is used by HI in the implementation of AWO systems. OpTex may be the only computer tool capable of integrating hundreds, if not thousands, of mathematical models, running on a parallel and distributed computer system. For those interested in learning more about OpTex, HI invites to watch the video OpTex, Optimization Expert System. Putting problems together is much easier than writing equations. That is the future of mathematical modeling, which OpTex has been experiencing for 35 years. Not writing equations is every mathematical modeler's dream. The traditional process of mathematical modeling implies that programmers, usually mathematical modelers or data scientists, must make great efforts to implement complex optimization models. Do you wonder how to make high-complexity large-scale artificial brains, without programming? The best way to make software is having to do it, is the goal of OpTex. The HI approach is aimed at developing cognitive robots, that eliminate the tasks of computer programming, since the robot takes care of this process. This enhanced the mathematical modeling capacity of the professionals. Making an enterprise-wide optimization system, integrating multiple large-scale models, using a computer programmer, is an impossible approach, because the programmer can only write a limited number of lines of good source code per period. Maintaining these models can be more complicated than making them, if there is more than one programmer involved in the process. Only a generative artificial intelligence can produce infinite lines of perfect source code in seconds. The foundations of Optex database algebraic languages consider the algebra as a standard, to express the relationships between the different parts that make up a mathematical problem. It can be said that there is only a reduced way to write an algebraic equation. This is independent of the symbols that are used to represent the physical or logical relations. Additionally, if two algebraic formulas are joined, a new algebraic equation is obtained that retains the same structural characteristics of the original equations. This transitivity law may be extended to mathematical programming, MP, which in essence is a collection of algebraic elements. Then it is possible to join two MP problems to obtain a new MP problem. It is also possible to divide an MP problem into two MP problems. The multiple models are assembled like a Lego game, which can have as many groups of tiles as there are models. Resuming, if the formulation of algebraic expressions is normalized, it is possible to have a standard way of representing a mathematical model that can be understood by another mathematical modeler, making it a standard for formulating MP problems. Additionally, the combination, or division, of MP problems generates new MP problems, which can be solved using many optimization technologies. Therefore, to facilitate the development of models, it is convenient to establish basic principles, norms or standards, of modeling, in order to enhance the use of models and ensure that they remain current over time, thanks to conceiving as a dynamic structure that adapts to changes in computer technologies. This implies, previously to the implementation of mathematical models, establishing a standardization manual that guarantees the understanding of the mathematical model, by any professional knowledgeable about the subject. This fact will result in the portability of mathematical models and the significant decrease in the implementation time. Optex GPT is the current research and development plus innovation project, based on artificial intelligence, focused on generating a new version of the Optex optimization expert system, fundamentally aimed at generating a new interface, for modelers and users, of Optex, based on GPT-type artificial intelligence. Following the principles of generative pre-trained transformer AI, Optex GPT will be the advisor that helps mathematical modelers, and professional users, when they require solutions in line with today's cutting-edge technology. Optex is focused on the implementation of artificial brains, conceived as a union of optimization models, with information systems. In the development and maintenance of high-complexity mathematical programming, Optex avoids the intensive use of resources for programming computers. The process of uploading Optex will be a more interactive activity through generative artificial intelligence, such as ChatGPT Omnichannel 4.0. In this way, the user will be able to communicate with the Optex model database, and use all the documents produced by HI for the management of the system. All through a conversation, out loud if you will, with Optex GPT. At the limit, if the user wishes, Optex GPT can perform the entire process in a single step, until the results are delivered. There is no need to store intermediate results. The basis of the Optex GPT conversation will be based on so-called prompting engineering, called by HI as the engineering of ideas. Optex GPT will be a specialized generative artificial intelligence to work in the Optex optimization expert system environment, which will be powered by mathematical models that exist in the current Optex database, and of all new models that will be introduced. Technical documentation that supports Optex, and the mathematical models developed, and general technical information. On the other hand, from this knowledge information, Optex GPT will help the user build new mathematical models. Several GPT models will be developed, in order to serve users with different levels of experience. The main product is the management of MES, Mathematical Modeling Information System. From the correct configuration of the MES, the modeler will be able to configure the required algorithms, link them together, and generate the computational code of their choice. Finally, he/she will be ready to run the multi-problem models. The data source for building a model can be the description of the real model, and/or the algebraic formulation, and/or pre-existing models in the OpText database. Another of the functions of OpText GPT will be aimed at supporting users in specific applications, to accompany them in the process of elaboration, or selection, of mathematical models, the loading of industrial databases, and the interpretation of the results. The main product is the management of IDIS, Industrial Data Information System. This work will be advised by OpText GPT. Based on the data model of the IDIS database, this includes the verification of the validity of the database, considering the metadata of each of the fields of the tables. As an advisor, OpText GPT will have access to a database of documents, some generic and some specific, to facilitate the understanding of the company-wide optimization system by the user group. The image shows the connectivity of the OpText and OpText GPT databases. The OpText GPT database stores different types of documents oriented to the models and solutions that the user handles. OpText Expert System Database, OpText Manuals, User Application Manuals, manuals of the work carried out for the user, and technical documents such as papers. Distributed Economic Dispatch. The coordination of two types of models are studied, economic dispatch and unit commitment. The problem will be analyzed from the point of view of Lagrangian relaxation. The algorithms used to solve optimization problems have evolved with the digital revolutions. In Industry 4.0, the algorithms used are standard and those based on large-scale optimization technologies, such as Bender's decomposition and Lagrangian relaxation. The models correspond to monolithic centralized models. In Industry 6.0, mainly in real-time problems, the proper modeling is based on distributed and autonomous models, based on consensus algorithms. This has led to the conception of an algorithm that Hai has called autonomous Lagrangian relaxation. That will be presented in this section. The problem of economic dispatch uses a monolithic model that is traditionally solved by large-scale optimization techniques. This problem can be solved in parallel, but it remains monolithic. Bender's decomposition is the most widely used and most recognized theory in solving DP and UC problems. To solve the problem, a master model and several subproblems are designed that establish an exchange of dual and primal variables. The master problem sends primal variables to the subproblems. Bender's theory works in the primal feasibility zone. Lagrangian relaxation is the alternative to Bender's theory and uses a similar architecture. To solve the problem, a master model and several subproblems are designed that establish an exchange of dual and primal variables. The master problem sends dual variables to the subproblems. Lagrangian relaxation theory works in the dual feasibility zone. However, Lagrangian relaxation is the basic theory of DP and UC in Industry 6.0. Autonomous Lagrangian relaxation theory (LR) is about solving the monolithic problem using large-scale optimization methodologies. Although the solution process may be parallel, the problem remains integrated and requires a coordination problem. ALR is about using a consensus algorithm so that each problem is solved independently, and the solution is obtained through a consensus among the players participating in the game. The rules of consensus are based on the Lagrange theory. There is no monolithic problem, there are n independent problems. To determine optimality, the advanced metering infrastructure, AMI, of all electric systems must match. To do this, each electric system knows all the AMIs and moves towards the Lagrange multiplier solution. The electric systems will move autonomously, following logical rules that guarantee convergence, for example, moving towards the average of the Lagrange multipliers. For static processes, this consensus rule ensures that the problem will be optimal. The problem of Lagrangian relaxation must be broken down into 4 problems. Master problem, in charge of coordinating the subproblems, and 3 subproblems, 1 for each entity of the system. To solve the problem, a conversation is established between the master problem and the subproblems, The coordinating problem sets values of the dual variables, marginal costs, and the subproblems return information based on the primal variables. LR worked in the non-feasible zone of the primal variables, and in the feasible zone of the dual problem. In this case, Lagrange theory indicates that there is only one Lagrange multiplier and, therefore, it must be equal in all subproblems. The convergence of the integrated problem is achieved when in two consecutive iterations, the value of the Lagrange multipliers remains constant. The image presents the use of Lagrangian relaxation to solve the smart grid problem. Each subproblem corresponds to a smart grid, and the master problem is equivalent to the smart grid control center. The relaxed restrictions on all smart grids are the demand for energy, and the generation of energy, and if applicable, it must balance purchases and/or sales with the utility linked to the smart grids. Marginal costs indicate the price of energy for each period. Considering that LR is a primal non-feasible method, to use its results at any time, it is necessary to implement a mathematical problem that recovers the primal feasibility. In this case, it is a matter of recovering the feasibility of the demand and the generation equations. The feasibility recovery problem can be independent and reside in the AMI. To do this, it is necessary to implement an empirical rule of consensus based on optimization. The evolution of Lagrangian relaxation, LR, in Industry 6.0 has been named by Hai as autonomous Lagrangian relaxation, ALR. ALR is based the mathematical principles of Lagrange theory but is aimed at modeling living intelligent systems, which are autonomous and do not require coordination problems. On the other hand, its greatest strength is the modeling of systems in real time, based on intelligent sensors. ALR can also be called distributed Lagrangian relaxation, DLR. To differentiate itself from distributed Lagrangian relaxation, DLR, Lagrangian relaxation can be called centralized Lagrangian relaxation, CLR, since the model remains monolithic, and is solved in parallel using large-scale optimization technologies. ALR is based the mathematical principles of Lagrange theory but is aimed at modeling living intelligent systems, which are autonomous and do not require coordination problems. On the other hand, its greatest strength is the modeling of systems in real time, based on intelligent sensors. ALR is about using a consensus algorithm so that each problem is solved independently, and the solution is obtained through a consensus among the players participating in the game. The rules of consensus are based on the Lagrange theory. There is no monolithic problem, there are n independent problems. To determine optimality, the advanced metering infrastructure, AMI, of all electric systems must match. The Industry 6.0 artificial brain does not require a system supervisor. So, autonomous Lagrangian relaxation is a consensus algorithm based on Lagrange theory. Quantum computing and artificial intelligence are two transformative technologies that, when combined, create quantum AI. This integration leverages the unique properties of quantum mechanics, such as superposition and entanglement, to enhance AI's capabilities to solve complex problems, optimize processes, and analyze massive datasets. Quantum computing operates on qubits, which can represent multiple states simultaneously, unlike classical bits that are binary, 0 or 1. This allows quantum computers to perform calculations at exponentially faster speeds, making them ideal for AI tasks such as machine learning, optimization, and data analysis. Optex Quantum AI is the version of Optex that produces algorithms that can be solved on quantum computers. It inherits all the AI features of Optex Optimization Expert System. We can affirm that Optex Quantum AI is the state-of-the-art of optimization. The reasons are: generative artificial intelligence to produce the codes of the algorithms without programmers, and access to the world's fastest algorithms. Quantum computing, unlike classical computing, is a relatively recent development. Its origins date back to the late 1970s, when it first appeared in science fiction. In 1981, Nobel laureate Richard Feynman was credited with pioneering the concept of the quantum computer. His rule of thumb was, if you can't explain it simply, you don't understand it enough. In 1985, David Deutsch formalized the concept of a quantum computer, marking an important milestone in the field of quantum computing. IBM Quantum Platform provides access to quantum computers, documentation, and learning resources in one place. IBM Quantum is building a large-scale, fault-tolerant quantum computer. In 2029, IBM will deliver a system that accurately runs 100 million gates on 200 logical qubits, unlocking the first viable path to realizing the full power of quantum computing. The first quantum advantage claims are emerging, but how will we know when it has arrived? Researchers from IBM and quantum startup Pascal explore this and other questions. Just recently, researchers at the startup Kipu Quantum claimed a runtime quantum advantage, where their quantum algorithm ran faster than specific-purpose classical solvers for dense, higher-order unconstrained binary (HUBO) optimization problems. They identified instances that were challenging for methods like Plex and simulated annealing and found that running their BFDCQO quantum algorithm on ever-improving quantum hardware reported faster approximate solutions. The results are impressive. BFDCQO can consistently achieve comparable quality and the yielded solutions for the tested instances up to 80 times faster than Plex, or up to 12 times faster than SA. They expect their runtimes to be soon orders of magnitude faster as hardware continues to advance. The results are inconclusive, indicating that the development of quantum optimization algorithms is under investigation. For this reason, HI carefully follows what is happening, to select the best alternative. Optex gives stakeholders an advantage by facilitating the availability of many real-life models applied with traditional methods, which can easily be used to conduct research and develop proofs of concept with quantum computers. Chaining Optex to the quantum algorithm. HI's approach to quantum AI is based on two steps. The formulation of the models is based on Optex, Optimization Expert System, which generates the programs without the need to perform programmer activities. The algorithm already coded for execution is sent to the quantum computer. Optex generates the algorithm in an appropriate computer language, according to the availability on the quantum computer. This linkage is one of the main research topics in HI. Below is the design that is being implemented. The expert system is Optex's AI approach. HI is not aware of a similar approach to mathematical modeling, and it has been used by HI since 1990. The Optex software generation involves accessing the AI expert system and processing its content, to generate the software on the selected optimization platform. Chaining Optex to super server in the cloud. In this case, the current one in the industrial environment, the programs are installed on a super server and solve the problem. The generation of quantum software in Optex involves accessing the expert system, to generate the software into a computer code according to the quantum computer. Like IBM Qiskit. Chaining Optex to quantum servers in the cloud. This is the new approach to the industrial environment in a short time. The structure of the Optex expert system supports the new functions required for the new interface. HI is working in this direction considering the studies carried out for the implementation of quantum AI. This involves the generation of new computational languages and their connection with quantum algorithms. Optex should be installed on any computer running MS-DOS where the programs to be sent to the quantum computer are generated. Software production is at the heart of highly complex mathematical modeling. To facilitate this process, HI offers its software factory. The production of enterprise web optimization systems, EWOS, based on the integration of prediction models with optimization models, has been a difficult challenge to face in most industrial and social organizations. This has led to a drop in potential productivity, which translates into higher costs, of all kinds, economic, environmental, and social, to achieve a certain standard of living. To do this, the interested party sends the technical document with the algebraic formulation and a test database, and HI sends them, in days, the result of the requested service, which includes basic user interface, technology transfer, linking to SQL databases, all commercial rights, information system data model, algebraic documentation, MS Word, source code in multiple optimization technologies, and mathematical models including large-scale optimization methodologies. The development time of a model, and its environment, depends on the original information provided by the client and the number of mathematical elements, sets, parameters, variables, and equations contained in the model. A standard model of 10 generic equations can be ready in 1 or 2 weeks. Testing the model requires a database that the customer must provide. Optex isn't a high-level artificial intelligence that makes artificial intelligences. That is robots making robots, that make robots, that make robots. Similar to Optex, from whom they inherit their characteristics. In this way, any company in any sector can have the high-quality software it requires to maximize its productivity and competitiveness. As George Bernard Shaw would say, imagination is the beginning of creation. You imagine what you desire, you will what you imagine, and at last you create what you will. Hyde tries to have the capacity of Bernard Shaw's imagination. Thank you very much for your attention.